Seal Aftermarket Products engineers and manufactures Toledo Transkit with the rebuilder in mind, including everything you need to get the job done right. Toledo Transkit is the #1 choice of installers because of all the intensive research and development that goes into each component in every kit. Like re-engineered valve body gaskets, preventing EPC damage by eliminating the shredding you get from original equipment, plus all of the extra essentials that are included, like spring and screen filters that should be changed at overhaul. Toledo Transkit even includes loose valve body gaskets that fit all 19 bonded separator plates. At Seal Aftermarket Products, we don't just make kits, we make kits better. Ask for Toledo Transkit by name.
The broadcast is now starting. All attendees are in listen-only mode.
Well, good day, everyone. I'd like to welcome you to the ATRA webinar series. Today's subject, we're going to talk about some Toyota transmissions themselves, the A750, both the E and the F series, which is a two-wheel drive and four-wheel drive series. Its six-speed brother, which is the 760, and of course the 761 series transmission, which is also out there. So a lot of information we're going to be covering today. This thing actually got quite a bit bigger as far as the handout than I'd obviously anticipated it becoming. You got about an 80-page handout if you take a look at it. I tried to put a lot of information in it, which would be resource information for you, so that you can come back at a later date if you got one of these things apart and find out which valves are where and so forth. So there's a lot of stuff we're going to be moving through at a very rapid rate for me to finish this thing in 30 or 40 minutes. Because again, I could spend a couple hours on this particular subject. So we're going to be scooting right on through it so we can get into some of the diagnostic stuff that we're going to have at the end of the presentation itself. So with that said, let's do a little bit of the housekeeping stuff. Again, we'd like to thank the guys from Seal Aftermarket Products for sponsoring all of our webinars that we've got. Again, appreciate those guys doing that. It allows us to bring the webinars to you guys at no cost, which is a great thing for the industry. If you're having a problem along the way here somewhere, probably the easiest way to get it addressed is to send Lance an email. Or if you have any questions about ATRA, send Lance an email at lwiggins@atra.com. He's over there at Oxnard right now, so either him or Sean should be able to get you a handout if you're missing a handout or if you're having some sort of communication issues or anything like that. So again, that's his email address. He'd sure like to hear from everybody. Connections. We've talked about this in the years past. Over this past 6 months or so, we've been doing webinars. Make sure you're a hardwired connection. Handout, of course, everybody should have received the handout. If you did not get the handout, make sure you get a hold of either Sean or Lance, and they'll help you get a hold of the handout itself. It is a PDF format handout, so again, you're going to have some sort of Adobe program in order to open it or print it. If you've got questions, we're running through this today. The simplest, by far, easiest way to ask a question is to click on the questions box, type it in, hit the submit key. It automatically pops up on my screen, and we'll be off to the races answering whatever questions you have. Following our presentation today, just like we've done in the past itself, you're going to have a survey, which is an automated survey. Again, appreciate people filling out the survey. So with that said, let's take a look at a little bit of the general information on the Toyotas themselves. This is kind of where this stuff all started at. These transmissions have been carried through, obviously, into later model years than what's on this chart. They're called out as a 5AT, which is the 750 transmission. So a 5AT and the 750 are basically the same thing. They have a couple different versions, the E version, which is the two-wheel drive, and the F version, which is, of course, the four-wheel drive. A little different chart that you're seeing right here popping up. What's different about this chart is it also shows you some of the Lexus models on there, as well as some of the gear ratios that you're going to see. We're going to take a look at the 750, the 760, and, of course, the 761. So let's look at an apply chart for the 750. Both the two-wheel drive and the four-wheel drive use the same apply chart. So this is a diagnostic chart, so if you're having problems with a particular gear missing or a shift that didn't occur, that sort of thing, this will show you which solenoids are applied when, show you which clutches and brakes are on, and when those components actually are active. The 760 is a little bit different. Again, it's a 6-speed version. So as you can see here, we've added another one-way clutch and so forth. There's other additional components here that you did not have with the 750 transmission. But again, you got an apply chart here so that you can physically look at which components are on when, and so that you can help diagnose whatever kind of ills you actually have with your particular transmission. This simply shows us a breakdown of the transmissions themselves, both the 760E and the 760F. As you can see, they're basically the same transmission. The difference is going to be the pans on these things and the rear extension housings, as you can see. So your output shaft can be a little bit different, and the extension housings are going to be a little bit different, and your oil capacity is a little bit different. Internally, they're basically the same units. So they operate the same way, you repair them the same way. So again, there's nothing really razzle-dazzle about this. As you can see, the F unit weighs just a hair more than the E unit weighs. It has a little bit more as far as oil capacity on the E unit than you have on the F unit. So again, a few little quirks, a little bit of differences, but nothing to be worried about. When you look at the 760 itself, as far as the layout is concerned, this is your clutch and brake and one-way clutch layout, as well as your planetaries. This basically tells you what clutches you have and where they're located at, as well as the same thing with the brakes and the one-way clutches. And it's also going to give you the tooth counts for all of your different planetary components, so you'll have an idea what you got there. Again, it's going to be the same between the E and the F version transmission. This is a very interesting slide that popped up here for you. This is an area that transmission technology is moving into. As most of you guys know, I spend quite a bit of time back at engineering in Detroit every year, and one of the things we talked about this last couple of years, probably the last 3 years or so, was the need to condition the fluid when it's cold. And many manufacturers, including Toyota, and now Dodge has done this with their new Ram trucks, they'll have ATF heaters on them, not coolers, but heaters. So you've still got your cooler, but they've added a heater to it. Toyota has done this just the exact same reason that everybody else has done this. Parasitic drain or parasitic loss when the transmission is cold, in other words, the amount of energy it takes to turn that transmission when it's cold is much, much higher than it is when it warms up. So they take the oil and they condition it via a cooler mounted to the transmission, which is actually a heat exchanger the opposite direction. It actually heats the transmission fluid to reduce the friction losses within the transmission itself and improve the corporate average fuel economy standard. So you're going to see more and more of this type of thing as we go down the road. Like I just mentioned to you guys, the new 2013 Dodge Ram trucks, they have a cooler on the left-hand side. It looks like a cooler. It's actually a heater, just like this Toyota is. So you're going to see more and more of that type of technology coming as we go down the road. So when you look at one of these Toyotas and you see that thing, that's what it actually is. It's actually a heat exchanger to increase the transmission fluid temperature when the transmission is running cold. Now, there will also be some valving and so forth in these units themselves. So again, if you're having some troubles with fluid flows and so forth, you're going to want to get yourself really aware of how these systems function. When it comes to filling these units themselves, very similar to many other transmissions like a 6L80, where you're going to have a standpipe. This thing is no different than that. You're going to want to get the transmission to the proper temperature. That's going to be really critical. Pull your overflow plug itself, and of course the oil should barely drip out of that plug. If it's running out, either you're over temp or you obviously have a overfill condition. If there's nothing coming out whatsoever, then either you are under temp or you have an underfill condition. So fairly simple. The process itself of filling this is no different than the process you would use with other transmissions to actually fill it with the transmission fluid. Now, all three of these versions of these Eisen-Werner transmissions are all using WS fluid. So Toyota WS is the fluid of choice here. You're going to find out that, again, all three of these use two temperature sensors, ATF temperature sensor number 1 and number 2. They're going to be listed on your scan tools at number 1 and number 2. We're showing you here what they're actually using those for. They're modifying line pressure for clutches and brakes for temp sensor number 1 and modifying shift patterns for temp sensor number 2. You can isolate which sensor it is by looking at your wire color coding. As you can see on the picture, I put the temp sensor number 2's got blue wires and temp sensor number 1 has got orange wires. So again, a little bit of reference information for you there. Some additional reference for you, line pressure checks. You're going to find that these transmissions do have line pressure taps. The taps themselves, so you can hook a pressure gauge to it. These are your line pressure specifications that you're going to have for the 750 right here. Now this is one of the interesting things I find about the Eisen transmissions. A lot of the Eisens do this. In fact, all three of these transmissions are done this way. The accumulator sleeve and the pressure regulator valve sleeves are all adjustable. So they can vary the spring tension on those valves by simply varying the position of the sleeve itself. So what we're telling you is make sure that you mark that sleeve before you pull it out. So in this instance, we're looking at the accumulator control sleeve itself, and there's the accumulator valve sleeve. Make sure you mark it before you pull it out so that you get it back in the same location. Pressure regulator sleeves in these Eisen transmissions are the same exact way. In fact, here's a picture of the pressure regulator sleeve we're seeing pop up right now. That sleeve itself, again, is going to have some steps on it. Make sure you put it back exactly the way that it came out so that you don't have a baseline pressure issue. So kind of a neat idea that Eisen has with adjusting both accumulator pressure and pressure regulator valve spring tension by simply adjusting the position of the sleeves themselves. We're going to give you several pictures of check balls. This happens to be the 750 that you're seeing here, the upper valve body check ball locations. Here's my upper valve body number 2 check ball locations. Again, these are going to be for reference, guys, so when you get one apart, you better look at everything. Here's my lower valve body, number 1, exploded view on the 750s, and which valves are which. So we're going to give you the call-outs for all those valves, again, so that you can isolate which valves you're looking at. Here is my upper valve body on the right-hand side. As you can see, we're listing all the different valves and so forth in here. Now, one thing I will precaution you about on the Eisen transmissions are famous for having worn valve issues. These 3 transmissions are no different. We're having a lot of valve body scrubbing issues with these, and so any valve that's a pulse width modulated controlled valve, you need to make sure that you check it. So bottom line, guys, is make sure that you take the time to inspect the valve body no matter how you decide to do that. Whether you're going to vacuum check it, you're going to visually inspect it, you're going to air test it, you're going to measure it. I don't care how you do it, but make sure you do it, because again, these transmissions are no different than any of the other Eisen transmissions. They wear valve bodies at a fairly rapid rate. Here's my upper valve body on the left-hand side, as you can see. Clutch lockup valves, solenoid modulator valves. And those modulator valves are very suspect valves in the valve body. So anything that's had any kind of solenoid oil pressure going to it with pulse width modulated solenoid or linear solenoid controlling it, you want to make certain that you check those valves. Upper valve body, you're going to see this is kind of carried over through the different units themselves. Coast brake relay valve right here. Upper valve body number 1, we're also showing you where the solenoid filter screen goes, so you'll know where that actually is located at. And now let's take a look at the 760. So we looked at the 750, let's look at the 760. The interesting thing you will find about the 760 is, look where the 2-3 shift valve is at. Upper right-hand corner of that valve body, you'll see the little note right there. It says also works as your 5-6 shift valve. So the 2-3 shift valve is not just the 2-3 shift valve. It's also going to be the shift valve that makes the transition from 5th to 6th gear with this transmission. Here's my upper valve body number 2 picture that's popping up for you right now. As again, you can see you've got a relay valve in there just like we had in the 750. And of course the lower valve body number 1 picture is showing your regulator valve and your 4-5 shift valve. Now here's your lower valve body number 2. Again, we've given you those pictures. I intentionally put all the pictures in here for reference information because these transmissions have got a ton of valves as compared to other people's transmissions. You know, you get into a GM or you get into a Ford or something like that, they don't have nearly as many valves as these Eisen Warner transmissions do. So it's kind of nice to be able to have a picture so that you can physically locate which valve it is that you're concerned about. On the 750s, you're going to find out that there are two types of regular on-off shift solenoids that are used. One is a two-way solenoid, the other is a three-way solenoid. So I'm showing you in this instance how the solenoids actually operate here, and I'm going to give you a little chart to explain the difference between a two-way and a three-way solenoid here in just a second. You're also going to run across solenoids that are linear solenoids. They're described with the terminology SL being used in front of their name. So an SL stands for solenoid linear. That's a fancy word for basically meaning that you're going to have something that's going to be pulse width modulated and it's going to vary its output pressure. So rather than being strictly an on-off style solenoid, it'll vary the output volume and pressure based on the current flow through the winding of the solenoid coil itself. As you can see, they got a couple different versions. Some raise pressure with current increase, some lower pressure with current increase, depending on which solenoid we're dealing with. This is a little chart to tell you what solenoids do what. So as we talked about, we got some two-way solenoids and we got some three-way on-off solenoids in the 750. So the S1 and the SR are three-way solenoids. So we're saying it's going to switch pressure from one passage to another one. So the S1 actually controls the 2-3 shift valve. The SR controls the clutch apply control valve. The S2 is strictly a two-way solenoid. It simply opens or closes a passage, and that controls your 1, 2, and your 3, 4 shift valves. And as you can see also down on the bottom, we've got 4 linear solenoids that are actually used in this transmission. The SLT, which is your line pressure, your trim solenoid, your SL1, your SL2, and your SLU. And we're showing you in the picture that you've got there what those components actually are used to control. So as you can see, we're going to control, like for example, accumulator back pressure with 3 different solenoids depending on which accumulator valve we're actually controlling. Now, a lot of guys get really confused when we start talking about these linear style solenoids. Here's how simple this is. This is really not a complicated process. We're going to have some input information that comes into your controller. In this instance, we're seeing that's the ECM. The ECM is then going to command an output action that's going to occur, which basically is going to end up being a current that's going to be fed to the solenoid. So we're going to pulse width modulate a voltage signal to control the current flow through the winding of the solenoid, which then in turn controls the pressure output of the solenoid. As you can see, that goes over to my pressure regulator valve in this instance to control the position of the regulator valve. So again, even though it looks like it's fairly complicated, it is not. Even though they call them something different in these transmissions and some other transmissions you may have worked on, this is nothing more than a glorified pulse width modulation style system that actually varies your line pressure based on the current flow coming from the ECM. Little chart to show you which components are on and off, obviously when you make the shift or gear changes. So this is my solenoid sequencing chart, again for reference. Put together a fail-safe chart for you. This shows you an example of one solenoid. So if shift solenoid 1 was to fail, what gears would you actually have as a result of shift solenoid 1 failing? So again, some more reference information for you. This is a layout of those 750E and F solenoids. So as you can see, we've got all the solenoids there on the screen, and you can see exactly what each solenoid does based on what we talked about before, and of course where those solenoids are actually located at. The 760, both E and F, this is a schematic for what those solenoids are as far as their location is concerned. As you can see, on one side of the valve body you've got 7 solenoids, the other side of the valve body you've got 2 solenoids. So we've got 4 linear solenoids, and we've got several other solenoids that you're seeing there. So again, a little bit more complicated than what we had previously with the other transmission. But the basics are going to be the same. So I've put together some charts here to help you understand what actually these solenoids control. So this is my 760 application chart, I guess you would call it, for the solenoids themselves. As you can see, S1, that's a 3-way solenoid. In fact, all these are 3-ways. You don't have any 2-ways here. All of them are 3-way solenoids, and it's in charge of the 1-2 shift valve and the SL1 relay valve. That's what it basically controls. So if you went down the chart to S3, you can see that actually is in charge of the 3/4 shift valve. So if I'm having a problem with the 3/4 shift valve not working, the S3 solenoid is where I would go. So that's the idea behind having the chart, to show you what components do these solenoids actually control. Same thing is true here when we get into the pulsive modulated solenoids. You're going to see the SL1, SL2, SLT, and SLU solenoids listed, and what components they are actually in charge of controlling pressure for. So if you had a lockup issue, you'd be going after the SLU solenoid as your lockup issue problem. Like any other electronically controlled transmission, you're going to have a controller controlling those solenoids. That means you're going to have some input data coming in order for the controller to be able to make the proper decision to be able to control the output command for the solenoids. The next couple pages simply show you the inputs and, of course, the outputs for this transmission. So as you can see, we've got the basic input things here. We've got mass airflow sensor, crank position, and so forth, APP, temperature sensor 1 and temperature sensor 2, the basic stuff that you've just seen before. Input speed, output speed, stoplight position, four-wheel drive input. So I guess my point is this is really no different than any other transmission that you've dealt with. You have to receive input data in. The controller's got to make a decision, command and output action to, of course, occur. So if we have skewed input data coming in, then you're going to have a problem with the output commands on the output side of the controller. So just keep that in mind. If the output side's not working right, you may have an input problem, just like any other transmission you've dealt with. We're showing you what happens if, in fact, you do have a problem with either the inputs or the outputs that are hooked to the transmission itself. So as an example, if you came the third block down, ATF temperature sensor number 1, what happens if it fails? It says, well, if it fails, you're going to have upshifting to the 5th and 6th, and flex lockup control will be prohibited. So what we're saying there is you're not going to have a 5th, 6th, or lockup. So this chart's designed to help you isolate where your issue is at, if in fact you have either a solenoid issue or an input issue that's attached to the transmission. The 761 is a cousin of the 760 transmissions. We first seen this when it came out in the Lexus. Not as many of these out there as there are 760s at this point, or 750s, but you will run into these. And again, very, very similar as far as operation, very similar as far as repair. The picture that you're having pop up right now shows you how you check the fluid level. Absolutely no different than we just did with the 760 prior to this. So you're going to want to make sure that you have the fluid temperature correct. Pull your overflow plug itself, which is your standpipe plug. Make sure that you do not have a bunch of oil coming out of there. If you do, you're either over temp or, again, you're over full. If you don't have anything coming out, you're either under full or you're under temp. So you're going to want to make sure that the temperature is checked before you check the actual fluid level, just like any other transmission with a standpipe. Again, just like the other Toyotas we talked about, the 761 uses WS fluid. This simply shows you a picture of the valve body itself bolted in place. The thing I want you to notice is going to be some of those solenoids are color-coded. So the connectors on them, and we're going to take a look at that here in just a second. In fact, here is the picture popping up right now showing you the ID for the different solenoids on a 761 unit. So as you can see, the layout is this layout right here. So if you had an S3 solenoid that you think you have a problem with and you wanted to get an S3 as replacement, there's where your S3 solenoid is located at. Pin locations on the 761. So which pins are where? What colors are they as far as your wiring is concerned? And what do they go to? Check balls. Check balls are a little different than what we dealt with here before with the other transmissions. So if you look at here, we've got 8 check balls in the upper valve body. We've got 12 check balls that are going to be popping up here in the main valve body. So again, check ball locations, they got plenty of check balls here, so you're going to definitely have to pay attention to check ball locations so that you don't shoot yourself in the foot. Most of these check balls are basically controlling apply rates of components. They do have some other check balls that they use it for different functions, but primarily they're controlling apply rates of different components. Valve body, no different than we've dealt with the 760 or the 750 transmission. As you can see, we're talking about the accumulator control valve itself with that sleeve being adjustable, and the pressure regulator valve sleeve, of course, is adjustable also. Again, no different than the other transmissions that we dealt with. Wear in these valve trains are quite common. So again, if you have one that comes in with clutch damage or a slipping type of complaint or anything like that, make certain that you check the valve body for wear. So anything that's had a pulse width modulated solenoid hooked to it, or that solenoid modulator valve that you're talking about right there on top of the screen, you're going to want to inspect everything for wear. There are several kits out there from the aftermarket suppliers to address these wear issues in the different valve train components. Here's my upper valve body number 2, just like it was with the 760 that we just got done looking at, or the 750. You got a relay valve built into there. Here's my lower valve body number 2. Your regulator valve and regulator valve sleeve. Again, that sleeve's the guy that's adjustable, so you want to make sure it's in the right position. And again, component locations for resource information for you. Here's the left-hand side of the upper valve body itself, showing you again which components are where. Here's the right-hand side of that valve body, showing again which components are located where. Now let's take a look at the accumulators. As you can see, we've got several accumulators in this transmission. The B1 accumulator located in the valve body. Several accumulators, as you can see down on the bottom of that picture, C1, C3, B3, C2. Those are all accumulators that you're going to have in this valve body assembly itself. I'm not sure what happened to my picture here, guys. See if I can get this thing back up here. That's not good. Okay, I think we're back up and going here. So anyway, the accumulators that you're seeing there, obviously along the bottom of the case area, the seals that we're showing you there in the middle of the case area itself, B1, B2, B3, just like you'd have with the 6L80 or any other transmission like that, you're going to have some seals that actually seal the valve body to the case. Make sure that those seals are in position when you bolt the valve body down. C1 clutch accumulator, again, what component it is, the spring dimensions for you, for resource information. We're going to take a look at the C3 accumulator, same thing again, so you know which component it is as well as what the spring dimensions actually are. B3 accumulator, same story, what component it is and your spring dimensions for you. C2 accumulator, as you can see, we have an excess of accumulators in this transmission. We have more accumulators than we know what to do with. Same story here. And now let's take a look at some of the hard parts in this trans. What we're trying to point out to you here is that this transmission is very similar to like a 4L60E. You're going to have an anti-rattle clip that basically keeps the clutches from rattling in the case. We're just precautioning to make sure that you get the anti-rattle clip in place. It's real easy to leave laying on the bench, and then you go, what is this clip? And if you leave the clip out, you're going to have a clutch rattle issue. Sprags, all the sprags are directional in this trans. You're going to have 4 of them. So we're looking at the F3 sprag as our first picture right here. We're going to use that F3 sprag in first gear. We're saying if you want to check it before you put it in, you lay it as we're showing it right here. Hold the inner race, drive the outer race. It should freewheel counterclockwise, and it should lock clockwise. That's what we're trying to show you there. Your brake F1, with it knotted into the case itself, we're going to take and we're going to drive the inner race itself clockwise where it should freewheel. That's what the arrow is trying to show you. it should lock when we try to drive it counterclockwise. When you get down into the planetaries, you will notice there are some plastic thrust washers. We have had some issues with guys not getting those thrust washers in right. That's the reason I put this picture in. Again, this is like some of the old 350 stuff. If you don't get that plastic thrust washer in, you're going to have any little tabs left on the thrust washer after all said and done. So make sure you get those down into the holes, glue them in place so that you don't have a problem. Here's my F2 sprag. We're showing you with the components assembled together that the F2 sprag itself should rotate in a clockwise position. So that's what the arrow's trying to show you. And finally, on my F4 sprag, again, it should freewheel clockwise, lock counterclockwise. So again, that's what we're trying to show you with the arrow. One of the other questions I get on these transmissions is, how does that cushion plate go in? How's that bevel plate go in? The little picture I drew down here is trying to show you how that bevel plate goes. You can see it in the picture. You can also see the little picture that I drew with the bevel facing up. That's how it's supposed to go into the clutch pack. All right, so now let's get into some of the diagnostic information on these transmissions. These transmissions, like all other transmissions that are on the market today, have a full array of adaptive learning capabilities. Toyota's made it fairly simple to redo the adapts, and I do find it kind of interesting looking at the Toyota information and talking to the guys from Toyota that they don't go about the adapts quite like everybody else does. They give you some rules. They're saying if you replace the transmission assembly, if you replace the valve body, or if you replace SL3 or SL4, or if you replace the TCM, you need to relearn the adapts. Most other manufacturers will tell you if you do anything to it that affects shift feel, they want you to relearn the adapts. Toyota's pretty specific about this. I'm not sure why they are, but the bottom line is if you're ever in doubt, simply relearn the adapts. So clear the adapts, and then we're going to have a process for you to follow. This is Toyota's process. They've got a drive cycle you go through, and they want you to go through the drive cycle multiple times. And there's two different throttle openings they want you to maintain. 15 degrees or less, or 15% or less throttle, 25% or less throttle. So we're saying make sure the engine and transmission are warmed up, get yourself on some level road, take it out and drive it at less than 15% throttle, let it go through the gears, do that over and over again until the shift feels good. Then take it and drive it at 25% throttle or more. Go through the gears over and over again until the shift feels good. At that point, they consider the adapts as having learned. So that's the simple process that they have you going through. Very easy to do. They kept it really simple, which I kind of like that, as compared to a lot of other manufacturers where you've got to go through scan tool interfaces and a bunch of other driving sequences and so forth. Now let's take a look at some product issues that you may run across. We're talking about, in this instance, 4Runners, Land Cruisers, Sequoias, Tacomas. Basically, all of these transmissions out here may run in a situation where you end up having a transmission fluid temperature sensor code, which is a 2742 code. The code is not caused by a bad transmission temperature sensor. It's caused by a harness issue. So they've updated the harness. So as you can see, under the current part number, that is their updated harness assembly. Tacomas, and you're going to see this on some of the other Toyotas also, a clunk, and the clunk is a bump on a stop. So you're pulling up to a stop sign, let's say you're coming off the interstate, and you're pulling up to a stoplight, and it feels like somebody bumped you from behind. If you run across that, it's a condition known as spline lock. And what they had troubles with was the interface between the prop shaft spline and the transfer case spline. So my point is, they have a problem with how those two sets of splines interface with each other. So they came out with an updated prop shaft for this. And the prop shaft is updated based on your wheelbase. So if you notice on the bottom of this, we're going to give you the wheelbases. Short wheelbase is 109 inches. Long wheelbase is 127 inches. Super long is 140 inches. And you simply order the prop shaft based on what your wheelbase actually is. As I told you earlier, the Tacomas are not the only ones to face this as an issue. The FJs, those cruisers, the little short box-like cruisers, or little square guys, those are also faced with the same exact issue. They've replaced it with a new updated prop shaft to address this issue also. Prindle switches. One of the areas that you may run across issues when you're putting the transmission back together is the Prindle switch area. What we're telling you here is make sure that the rooster comb and your detent lever are in contact with each other before you put your Prindle switch on. So we're showing you incorrect on the left-hand side. We're showing you correct on the right-hand side so that you do not over-travel that switch assembly. So make sure you're locked into the correct position before you slide the Prindle switch onto the shaft itself and do your adjustment for that. Forerunners. Let's talk about forerunners with 750s. You're going to see it again. This is quite common on some of the other Toyota transmissions also as we get into this a little bit further. Here we're talking about a forerunner with a 750, a shutter on a 1-2 shift. Just like other manufacturers, guys, they don't go into the transmission to fix this. They're doing this via calibration. So the calibration itself, you're going to load. That will take care of the issue. Now, some of you are probably saying to yourself, well, I've never done a Toyota calibration. In June, we're going to have a webinar on doing Toyota recals. So again, feel free to pop into the webinar in June because I'm going to be talking about doing Toyota recals. So if you've never done one of these, you'll find out it's probably the second simplest recal process that's on the market. There's some of them that are very, very, very complicated, but Toyota makes it very simple to do the process. Leak from your yokes on the FJ Cruisers. So you got a prop shaft that's dribbling oil. Most of you guys remember we had troubles with this on the 4L60E, four-wheel drives, and so forth. So basically the same thing here. The end plug itself is leaking a little bit. If you decide that you're not going to want to try to fix that, you want to replace it, then they're going to sell you a new prop shaft for it. Most guys will simply clean everything up and try to seal that end plug the best that they can, and 9 times out of 10 that takes care of it. Toyota's solution again is going to be simply to replace the prop shaft. Now you're going to see this type of complaint here. If you got popping up hard shifts, we're talking about a forerunner and FJ. You're going to see this on every one of the Toyotas that has a 750. Speeds below 20 miles an hour, 2-1 downshift, aggressiveness is quite common across the board. It is not a problem inside the transmission. It is a problem with the calibration. So there's an updated cal, and you're going to see we're going to talk about this numerous times for each of the different models. There's an updated cal for each of those different model transmissions. So now let's talk about Sequoia and Tundras, the full-size trucks, talking about issues with the C1 clutch, possible trouble codes being set, finding distress in the C1 clutch. If you run across that on a 6-speed Toyota, make sure you update the calibration. It may not be a problem relating to the clutch itself. So you may have some trouble codes set, may find the clutch damaged. Make sure you have the updated calibration in it because that could be what's causing your issue. All right, Tundras may set a code 705, talking about 2007 Tundras with 4 mounted shifters. Mill lights on, may also have these other concerns. Prindle doesn't want to work in the dash. You can't get the truck out of 4-wheel drive low. You have delayed or harsh engagement into reverse or drive. This is kind of an interesting one. This is on vehicles that tow trailers. And what they isolated this to was the circuit that feeds the trailer plug. They were taking the power off the wrong circuit. So they've got a new harness for the back end of the truck itself, which is the backup light circuit, to feed power off of a different circuit. So you're going to have to update a wiring harness component itself to address this issue. So if you're running across an 07 Tundra that has any of these complaints, you're going to want to simply update that harness. Again, you guys are in the Midwest, so you've probably seen this happen already. Had some pretty cold weather back in the Midwest right now, so we're talking about Tundra vehicles here, turning on the service oil temp light in the dash of the truck itself. Again, there is a calibration to address this. So if you run across a customer saying, hey, this little light bulb comes on in my dash, check the calibration before you start working on the truck. Now, as we talked about that hard shift concern before, I told you at that point that pretty well all of these Toyotas have had this as an issue. This is an example. The Land Cruiser one here, 08s to 2011s, had the same exact issue, repairing it the same exact way we just did with the 4Runner that you've seen before, which is simply going to be doing a calibration change. Land Cruiser shutter issues. Where we've seen most of these issues are problems with people who go off-road with these trucks. Just had a webinar we did in Australia yesterday. In Australia and New Zealand, these trucks are common as can be in Australia and New Zealand. And they've seen a ton of these where guys go off-road, they get them obviously submerged a little bit in water, and they get moisture into the transmission. We're talking about shutter issues, noise issues, and so forth that you may run across. What we're telling you to do is look at your oil. If you see evidence that there's been water getting into the oil, then the water most likely came through the breather. So they've redesigned the breather for this transmission. So again, if you see water contamination, that's what's causing your issues. Depending on, again, what kind of situations you have, very good chance you're going to go in and you're going to have to put a soft parts kit in this, including a torque converter. Just like we talked about with the other transmissions here, or other vehicles, I should say here a little bit earlier, hard 2-1 downshifts, 20 miles an hour or lower, you're going to have a revised calibration to fix that. Well, as you can see, that's pretty well taken us through quite a bit of information here. We've gone through a whole bunch of slides here today. Hope you guys have enjoyed yourselves. Again, appreciate the guys from Seal Aftermarket Products sponsoring us. I don't see any questions popping up here. So with that said, guys, I appreciate you attending. The next webinar we're going to have is going to occur pretty quick. We're going to be doing a webinar on the 22nd, which is going to be a week from today. So we did not have a 2-week spacing on this. It's going to be on Ford reprogramming is what we're going to do a webinar on. So again, if you want to get into reprogramming, you want to learn a little bit about the subject itself and see how simple it is actually to do the reprogram, I'm going to take you through from step to step, just like we did the GM reprogramming one we did here before the first of the year. So again, hope to see everybody then. With that said, guys, have a great week, and we'll talk to you next week.
Seal Aftermarket Products engineers and manufactures Toledo Transkit, the most trusted and complete kits in the industry for 25 years. Toledo Transkit gives you more critical components, more OE components like premium seals and gaskets, more design enhancements, patented components, and all the little extras you won't find elsewhere. With kits for over 250 different domestic and import applications, distributed globally. If you want the best sealing transmission kit in the industry, ask for Toledo Transkit by name.